Okay, guys, so first thing we're going to talk about is cold air and hot air. So what do you guys think is taking place on this picture? What is taking place with the hot air? What is taking place? What are the molecules doing? Go ahead, Josiah.
In hot air, they're moving very, very fast.
Hot air, they're moving very, very fast. Do y'all agree?
Yes.
Why do you think they're moving fast? Go ahead, Jason.
Because they're boiling.
Huh?
They're boiling.
Okay, we're talking about hot air, but I mean, you're on the right track. You're on the right track, Jason, but we're talking about air, not water. Go ahead. They have more energy, exactly. They have more energy. Go ahead.
When heat is added to a substance, the atoms get faster and they spread apart.
Exactly. When heat is added to a substance, guys, the atoms, they spread apart. They move faster. Their energy levels increase. Yes, sir, man. Last one.
They want to spread out because if they're hot, they don't want anyone near them.
That's true. That's true. That's how I told you guys to try to remember it. Like, whenever it's hot, you don't want that many people around you, do you? You want get away from me. Well, that's how the molecules react. Whenever they're hot, they move around fast and they're spread out. Now, let's talk about the cold air, guys. Let's talk about the cold ones. What's going on with that cold air?
They're all like close. All the molecules.
You see the direction they're going? Like, these right here, they're moving. You can tell by the lines that they're moving much faster. These right here, Erica said that they were close together. What about their energy levels? How are their energy levels? Low. They have low energy levels, right? That cold air is causing them to have low energy level. What are the molecules doing? They're coming together and they're sticking together, correct?
Yes.
How are they moving? How do they move?
Vibrate.
They vibrating in place. Yes, they're vibrating in place. They move. They have very little energy. They're vibrating in place. That's exactly why solids are solids. Because their molecules are not froze, but of course the water is froze, but their molecules are stuck in place, guys. No movement, vibrating in place, little energy. So I must touch on this about the phase changes, guys. We know that temperature, it does what? How does temperature and heat compare? See if y'all remember that. How does temperature and heat compare, Josiah?
Temperature measures them out.
That's it. That's all you need to say. That's all you need to say. Temperature measures heat. Temperature measures heat. What else was I going to say? I just want to make sure we know that. Tell your neighbor, class, temperature measures heat. I need y'all to tell the ceiling. Okay, temperature measures heat, guys. Phase changes, guys. So, what is the boiling point of water? Good. Boiling point? So the boiling point of water is 0 degrees Celsius.
Yes.
No.
100 degrees. 100 degrees and then the rest is 0 degrees.
Jada, why you say that? Jada, why did you say that? Huh? No, the boiling point is 0?
No.
Think about that. Isn't it real cold at 0 degrees?
Yes.
So how would you expect anything to boil? It has to be hot to boil. You know the boiling point. We just went through this. What's the boiling point, Erica?
The boiling point is always at 100, and you know this because the other two are always at 0.
Yes, the boiling point, guys, is always going to be at 100 degrees Celsius. It's 100 degrees Celsius. Now, what about the freezing point?
Always 0.
0 degrees Celsius, right?
Yeah.
Okay. And what about the melting point?
0.
0 degrees Celsius. All right. So whenever we talk about Warren, pay attention. Thank you. I know you got to. It's okay. All right. So whenever we talk about the boiling point, guys, how is the heat energy, which is the molecular motion, does it become stronger or weak?
Stronger.
It becomes stronger, and what does it do?
The molecules.
What does it do? They break what? They break down the molecules. They break them apart, guys, and they start to spread out and gain energy. All right? Now, at freezing point, What are we doing? Are we adding heat or are we removing heat?
Removing.
We are removing heat at freezing point. As you remove the heat, what happens to the particles?
They get close together.
Huh?
They get close together.
Okay. So the attractions between the particles become stronger. The particles are starting to attract towards each other now because we're removing heat, making it cold. So now the particles are coming together, and that causes freezing. Now at melting point, it's 0 degrees Celsius like freezing point, right?
Yes.
But is melting point going up or down? It's going up past 0 degrees Celsius? Or is it going below 0 degrees Celsius? Yes, it is going up. And those particles, as you add heat, the heat energy, it allows the molecules to move around each other. They allow them to move freely, guys, to move around each other and move freely. So what's another word that we use for energy? Heat. Thermal energy is heat, guys. Thermal energy is heat.